All right. Hope Pre-Calc students doing a walkthrough for vectors quiz 2. We have vector u with a component of 4, 9, vector w with a component of -12 and -11. And so if you have vectors 4, 9 and -12, -11, you have u minus w. So u minus w would have components instead of 4, 9, -12, -11, you would have, right, components of 4 and 9 minus -12 and -11. 4 minus -12 is going to be 4 plus 12, which is 16. And 9 minus -11 is going to be 9 plus 11, which is going to be 20. So our component vector will be 16, 20. Great. Let's go to the next question. Vector v has components of 4 and 12. So we need to find 3/4 of vector v as a scalar. So if we have 3/4 times 4, 12, right? So 3/4 of vector v, that's equal to 3/4 times 4 and 3/4 times 12. So that becomes 3 times 4, that's going to be equal to 3 times 4, that's going to be 12/4 over 3 times 12, 12/24 over 36/4. And so 12/4, that's going to equal 3. And 36/4, that's going to be 9. Remember, 4 times 3 is 12. 9 times 4 is 36. All right, so our component vector is going to be 3, 9. Clearing annotations. Which vector equation matches the vector operation shown in the diagram below? All right, we have A, B, and C, all vectors. So what we can do is we can look at each vector, look at each equation, and see if it's true. Vector B plus vector A equals negative vector C. All right. So first off, if you were to add vector B and vector A, they would have to start at, they would need to be aligned tail to tip instead of just starting at the same position. So with that being the case, though, you were to take vector B, instead draw it at this point. That would be vector B plus vector A. And so if you want to draw vector B plus vector A, the resultant vector would look like that, which clearly has nothing to do with negative vector C. So we can cross out A. Let's do vector A plus vector B, which once again would not equal vector C. And let's look at B minus C is equal to vector A. Well, vector B plus, remember, negative C. So vector B minus vector C is the same thing as vector B plus negative vector C, which is what this is equal to vector A, which is true because the beginning of vector B, or vector A, is the beginning of vector B. And we'll end at the end of negative vector C, which is what we're adding here. This will be answer choice C. All right. Also, once again, you can always look through the explanations here. If we follow the path of B and then negative C, we end up in the same place as A. So in that case, remember, we start here, and end up at the ending place at A. So that's why you can add the questions. All right. Vector V, x, y, so that's x, y, and vector V has a magnitude of 3. So fill in the blanks to complete the following sentences. Vector W has a magnitude is going to be equal to negative 3x, negative 3y, as opposed to vector V having a magnitude of x and y. So here's the deal. If you multiply a vector by a scalar, the magnitude of the new vector is going to be the magnitude of the old vector multiplied by the scalar, and then take the absolute value of it. So vector W is going to if vector W is equal to 3 or negative, that vector W is equal to negative 3 times vector V. So the magnitude of vector W is equal to the absolute value of our scalar, negative 3, times the magnitude of vector V, which means it's going to be equal to the absolute value of negative 3 times positive 3. Negative 3 times positive 3 is 9, so that's going to be equal to the absolute value of negative 9, which is going to be equal to 9. So our magnitude is 9. Looking at vector Z, it's going to be 3x times 3y. So instead, vector Z, instead of having a negative 3, it's just going to be equal to 3 times vector V, which is going to be equal to find the absolute value of vector W. That's going to be equal to the absolute value of 3 times 3, which is the absolute value of 9, which is also equal to 9. Now we need to say match each defined vector above to a vector that could be its equivalent. So vector V and Z are both facing one direction because the x and y are positive, except for vector W is multiplied negative, so it would be in the opposite direction. So vector V and Z have to be facing the same direction. So I'm going to say switch right here, because V and Z, they need to be facing the same direction, because V and Z have vector V is positive 1 as a scalar, vector Z is positive 3 as a scalar. Well, W has to be going the opposite direction because you have a scalar of negative 3, changing the direction. And also W and Z have to have a lot bigger magnitudes than V, because W and Z are multiplied by a scalar with an absolute value of 3. So because of that, V has to have a shorter magnitude than W and Z. So this should give us the right answer. Moving on to the next question. 4u minus 2w. So 4 times u, so is going to be equal to 4 times 1, which is 4, and 3 times 4, which is 12. And vector w is going to be, and we're subtracting, remember we're minus, so we are subtracting 2 times w, that would be equal to 2 times 1 is 2, and not 2 times 9 is 18. And we subtract across, so because we are subtracting, 4 minus 2 is 2, and 12 minus 18 is negative 6. So that is our new component vector. Positive 2, negative 6. All right. Vector quiz 2. That's the video.